Hello, Legacy students. So as you can see, this video is just a little different than normal. We're going to be graphing some polynomials. You're going to want to have a graphing calculator like I have on my right-hand side here. You're going to want your foldables or foldable, there's only one. And then you're going to want your notes as well, so you can glue it in there. So first thing, what are we going to be doing today? We are going to be graphing polynomials using technology, and we're also going to identify those key features of these graphs. But first, let's do some investigation. So I'm going to show you several different graphs over on the left there. And I'm going to want us to identify quite a bit of the information. I'm just going to kind of point out things as I'm going through each of the graphs. So the first one I'm graphing is x cubed plus 2x squared minus 3x plus 5. So notice the general shape of him. He's kind of like an N, if you want to call it that. He only has one x-intercept. He does turn twice. He looks like he's going down on the left, going up on the right. X to the fourth, notice it's kind of like a U, kind of like a parabola, but it's kind of dented on the right. This guy has two x-intercepts. It only turns once, though. This one's an x cubed, negative 3x cubed plus 2x squared minus 3x plus 5. Again, this one only has one x-intercept, and notice it's kind of like an N again, but it's kind of stretched, kind of weird. Only one x-intercept again. This one, though, is different than his x cubed friend. This guy is rising to the left and falling to the right. Unlike his friend, this guy, he was opposite of that friend. I wonder what's causing that. And then we have this negative 2x to the fourth. Notice he's upside down from his last friend, but we still have that U-like shape going on. Still only two x-intercepts. It only is turning once there. And then we have this x to the fifth. Again, we have that N-looking shape, or like a sideways S. Ultimately, we have only one x-intercept, and we're turning twice on that one. Then we have next to the sixth, a little bit more of a U shape again. That U shape, though, notice how it's kind of consistently happening with guys that are even degree polynomials, right? Like this guy right here, he was even. It was a U shape. Now you're probably thinking, well, Marsh, why upside down? Well, that negative, do you see this negative right here? This negative is causing us to go upside down because it's flipped, just like normal. Like when we would do our parent tables, we would change the signs on all of those. So same thing is going to happen on those cubes. Those cubes are making ends, but the ends are going to be either upside down or kind of like a mirror image just because of that negative. So, and behavior. This is on the front of your foldable. Let's do a quick little scratch of it. If we have an even degree, that means squared, fourth, sixth, and then let's say we have a positive leading coefficient. What you're going to have for a little graph, and I'm going to do a little drawing here, is you're going to have a graph that's going to be pointing up on the left. And here's the thing is, though, we don't know really what's going on the right. We know it's going to go maybe up or down a couple of times. It possibly could. It could also just go up and down once, like kind of like the U's we've been noticing. So what I'm going to do is kind of like a scritchy scratch in the middle because I don't know really what's going on the middle there. But I do know, again, on the right, it's going to point up. So on the left, it's going to point up. And on the right, it's going to point up to positive infinity on both of those. But if it's an even degree and it's a negative leading coefficient, aka a negative in the front, it's going to point down. But we still don't know what's going on in the middle, so we're going to do a little scratch in there. And then we're going to point down. And then what it's going to do on both sides is we're going to point negative infinity on the left and the right. But an odd degree polynomial, what it's going to do is fall to the left and rise to the right. So ultimately, we're going to do something like this. But again, we don't really know what's going to go on in the middle, so we're just going to do a little scritty scratch in the middle there too. But it is going to go up to the right. So on the left, we are going to negative infinity. But on the right, we're going to go to positive infinity. Same thing, odd degree, negative coefficient. It's going to go backwards. So it's going to look like you are falling. But again, we don't know what's going on in that middle, so we are going to do a little scratch in the middle because it could go up and down several times, actually. Kind of like a roller coaster look. So we're going to start at positive infinity, but we're going to end at negative infinity. Now, reason why we're talking about this, you're like, do I have to like be able to produce this on command? No, but here's the thing. When you're graphing a polynomial, calculator, by hand, whatever you want, and you get something that is an even degree, but yet it's pointing to the left and pointing to the left, it's going down, and pointing to the right, it's going up. That should make you stop because of this little chart. You should always know that if you have an even degree, aka highest exponent, you should see both arms pointing up or both arms pointing down. If that doesn't happen, that is a problem, and we know we need to identify, did we type into the calculator wrong? Did I just graph? Did I miss an intercept? Did I miss a min or a max? We do have to pay attention to that. Now, when we are graphing these, we have to use our graphing calculator because unfortunately, in our abilities, we cannot find maximums and minimums by hand. That actually requires calculus. So we can't do it by hand at this time. So what we're going to do is we're going to use the graphing calculator to help us identify the kind of decimal approximations of minimums and maximums. And we're going to do these steps several times to graph these particular graphs. The first graph that I want to graph with you is x cubed minus 4x squared minus 9x plus 36. So first, we'll go to our step number 1. We're going to type into our equation in the y equals. So please make sure you push the turn on your calculator, right? Then click y equals. And then we're going to type in that particular function. So we want to type in x, remember your x button's right here. And then we're going to go caret key, that's how you get to your cubed. And go over. Make sure you get out of exponent land by pushing to the right. Minus 4x. And then there is a squared button. It's right here. It's by the comma. Minus 9x plus 36. Okay. I'm going to clear my key press so you guys can see my key presses here. Now, I'm going to go back to my instructions. We're going to hit graph. Let's hit graph. Now, notice this graph is really good, but the thing I did notice is I am missing the maximum, right? It's somewhere off up here in the graph. I want to be able to actually see it. So I need to change my window approximations to make it so I can see the maximum and the minimum. Right now, I can see the minimum. It's available. Normally, you should be able to click zoom 6, and that'll get you back to a 10 by 10 graph. Again, though, this is a normal 10 by 10, and it's not showing it to me. So I am going to go into the window, but first, I'm going to go see what can I change. I really don't need to change the x values because I can see the maximum and the minimum. They're in the range of x's that I'm part of. But I can't see up. I need more positive y, right? So I'm going to go to the window. I don't need to change how small my x values are. I don't need to change how big my x values are. I don't need to change the scale factor. I don't even need smaller y's. We said we need bigger y's. We need to see the bigger y's. So what I'm going to do is I'm going to type 40 just to see. And then I'm going to click graph. Now, I am able to see the maximum. Notice it's a local maximum because we are going to infinity, but I do have the local maximum and the local minimum both available. So now, since I can identify them and I can see them, I'm actually going to use the rest of my calculator. So step 4, I'm going to click the second trace. So I'm going to click second and then trace. It's right beside graph. And I'm going to first identify our minimum. So I'm going to arrow down to the minimum. Now, you could do the maximum first, but I'm going to do the minimum first. And now it's wondering about the left bound. That's basically saying, where is the left of the minimum? So I'm going to push the right arrow and notice the little X is going to move. And it wants me to be the left of the maximum or the minimum. Now, you're probably thinking, well, Marsh, how far left? Like really far left? Really, really close? It honestly doesn't matter. You could click right here. You could click right here. You could even click right here. I kind of go about in the middle there. And I'm going to press enter once I'm to the left of it. Now it's wondering right bound, aka where's the right of the minimum. So again, I'm going to keep pushing to the right. I'm going to make my little X move until I'm to the right of the maximum or the minimum. It doesn't matter how far right, just like it doesn't matter how far left. It's as long as you are to the right of it. I'm going to press enter. And then it asks you to guess. I honestly don't understand why this function exists, but we're just going to press enter again. And it's going to identify our minimum. Notice it's really gross ordered pair, but that's all right. So what I'm going to do over here is I'm going to write that down. It is my minimum, and it is a local. So I'm going to make that down 2. And I'm going to just give myself about 2 decimal points. So 3.52 is my x, and my y is negative 1.63, roughly. So now, here's what I want you to do. I want you to identify the local maximum by pausing my video, typing it into your calculator, using our steps that we just did. But notice we're going to start at the spot 4 because you already have everything typed in. And you're going to type in option 4 this time, not option 3 because you don't want to find another minimum. So go ahead and pause the video and try to find the value. Make sure you pause. Don't wait for me. Okay, betting you paused or you just waited through that very awkward silence. So I'm going to go identify that maximum. So again, I'm going to click second and I'm going to click trace, just like last time. Clear my key press. You guys can see what I'm going through. And then I'm going to go max. Okay. Now it's wondering what's to the left of the max. So I'm going to make my turtle, my little X guy here, move around. And I get to the left of the max. Again, it doesn't matter how far left as long as you're on the left. I'm going to click enter. Then I need to be to the right. There we go. And now I need to guess. I'm not going to guess. I'm just going to press enter again. There is my maximum. Notice the little X guy is actually off the screen. But I am going to go make notes of this maximum. He is located at negative 0.85. And 40.15 is where he is. My goodness, really far off the graph. So what I'm going to do over here is I'm going to go graph those dots. So 3.52, negative 1.63, that's right there. And negative 8 that's right. He's like all the way up there for a maximum. Okay, so now what we're going to identify the rest. Degree. Remember, degree is the highest exponent. So make note of that. Let's write that here. So your degree is your highest exponent. So my highest exponent on this guy is a 3. He has the number of possible roots. It's the same as your degree. So I'm going to mark that down. And that is 3. So this guy has 3 possible roots, but it is the same as your degree because the fundamental theorem of algebra, it's going you guys have been working on for that. Max number of turning points. Now, normally it is a maximum. Now, notice it's not going to use all of them, but in our case, this guy is always going to be degree minus 1. So in this case, this guy has the ability to turn twice, which it used all 2 turns. Notice on my graph, 1 turn, 2 turns. We're going to do even, odd, or neither. We can look on our calculator here, actually. Doesn't fold over the y, so it's not even. And it definitely doesn't fold over odd, so it's definitely a neither graph. It is not bounded in the slightest, but it is definitely a continuous graph. The domain, it looks like it's negative infinity to positive infinity. And the range also looks like that as well. Increasing, you know what, we're going to wait with that until we actually get our graphs. And then we're going to do end behavior last too. X-intercepts. X-intercepts, remember we said equal to 0. You're probably looking over at the graph there going, hey, Marsh, I can see them. I know, but we're going to prove it here. It is a 4 terms, and it looks like I can't do anything with quadratic. So what I'm going to do is I'm going to group these guys and hope that they factor. Factor out an x squared. Factor out a negative 9. Oop, they matched. That's a good sign. Okay, x squared minus 9. That guy factors again, so that's x plus 3x minus 3. Okay, so it looks like my 3 x-intercepts, I have one at negative 3, 0. I have one at 3, 0. and I have one at 4, 0. So I'm going to go graph all those dots in there. You got 4, 0, 3, 0, and -3. Okay, now it is honestly connect the dots game. So I'm going to connect my maximum to that. Hopefully you guys can draw better than I can. I'm going to go through this dot, bounce, and then go up. There we go. Something that looks like that. My y-intercept, plug in 0 for all of my x's, and it looks like it to be 36, because 0, 36, right? Increasing intervals. Now, this guy's kind of different. It looks like we started increasing at negative infinity, and then we stopped increasing right here, which is the x value of our maximum. So we stopped increasing at 0.85 negative. I know, kind of weird, right? And then I started increasing again at the x value of my minimum, which is 3.52. And then I kept going forever, increasing. But decreasing, we only decreased once, and that is between our min and our max. Really messy. Sorry, guys. And then my end behavior. We actually have to write two of them because they go different directions. So as my x is going to negative infinity, so on the left, my graph is pointing down. So I got to say I'm going to negative infinity. But as my x goes to positive infinity, my y is going to go to positive infinity as well. The next graph, what I would like you guys to do is try it on your own. You should be able to get your maximum and your minimum. I'm going to show you guys what that graph does look like, just so you make sure that you type it into your calculator, right? And I am going to guess that we're going to get, oops, Marsh is pushing buttons, plus x cubed minus 4x squared minus 4x. I am going to go back to my normal Zoom standard window. So this guy has 2 minimums and 1 maximum. So you do have to find all 3 of those extrema as you're finding them. And that should help you find the rest of your graph. We will check them when you get back, so that way you can make sure you have the right answer. But until then, I will see you later, Sabers.